Engineering practices for establishing quality here on Programming with Palermo.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
The first pillar of the Clear Measure Way is to establish quality. That's what we're going to talk about here on Programming with Palermo. Hi, I'm Jeffrey Palermo. I'm your host. We're going to talk about the essential 7 engineering practices that help your team establish quality from the beginning of a project to the middle to the end, whatever phase you're in. You need to catch up with these practices or establish them with a new application. And we're going to go through one by one, talk about them. A few of them have some demonstrations, but the first thing that you have to do is establish quality. You are not going to get anywhere if you're constantly chasing problems, chasing bugs, fixing things that are going wrong with your system, accidentally breaking things in some other part of the application every time you make a change. So let's dig into it. All right, so let's get into it. Without first establishing quality, software developers end up spending time finding and diagnosing and fixing all the bugs that pop up. And this robs the team of the much needed capacity for new features and enhancements. Trying to add features without first establishing a high level of baseline quality is kind of like budgeting based on a credit card rather than actually having an income. There's no way that the budget is going to balance ever. And it's only a matter of time before the situation comes crumbling down. We want the entire team's capacity for features and enhancements, not fixing things, diagnosing things, chasing down, wondering why something's not working, okay? So the first thing that we need to do is establish quality, and then we keep it there, okay? That's one of the pillars of the Clear Measure Way. So I'm gonna go through 7 of the essential engineering practices to help you and your team establish a high baseline of quality. And just go through them briefly. There's a lot of practices that can help you with these, but I'm going to cover 7 which I believe are absolutely essential for any .NET development team. First, we're going to go through and look at an automated private build, then test-driven development, then onion architecture, which is really dependency management and proper factoring of logic where in your Visual Studio solution your code goes, then static analysis, then pull request checklists, then continuous integration, and then automated full system acceptance tests. So let's just go through kind of one by one. And first of all, the private build. The answer to the question for a private build is my change ready to commit to source control? If it's not, it's just a waste of time. If it's broken, if I broke something else, if I don't know I broke something else, then I'm wasting my team's time even looking at it, or the integration build's gonna fail. Either way, am I ready to actually commit to my feature branch in source control? So let's just look at a private build. Now, I have a source repository. The link is in the show notes, but I'm just gonna show you what this is. By the way, this is the solution right here. I have it open. And I kind of like running my terminal right there in Visual Studio instead of a separate window because it's kind of nice. So I have a helper file, click to build.bat, and let me just run it. And this is my automated build. This really simple automated build, and by the way, I've left the kind of warnings on. So I'm going to restart this because I had the app running. So I love doing that because you'll know if there's a problem. All right, so version number 1.0, debug build, and it's running. While it's running, I'm just going to walk you through this. It's in my solutions item. We'll come back to the output in a minute, but build.ps1. This is the file, and this file, oh, by the way, it's running some full system tests. I'll kind of pull this off to the side, and I'll pull this off to the side as well.
Programming with Palermo is brought to you by Clear Measure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, Clear Measure can help. while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
So these are templates. Sorry, these are just variables at the front. And I invite you to take this template and just make it your own. And from every Visual Studio solution to the next, you'll be able to, oh, there's a full system test popping up right in front of me. I'll kind of show you that in a minute. And first of all, we kind of delete some old folders. We do a .NET clean, .NET restore. Then we do a compile, of course, without the doing a restore again, which speeds it up. Then we do unit tests, integration tests, and we do that explicitly, collecting our code coverage metrics, things like that. And the acceptance test, you can choose to run that in your private build or not. It probably depends on speed. Initially in your team, you'll want to run those, but then they tend to take a long time, so teams end up kind of pushing those to a separate stage. And then we also have migrating the database so that locally every team member has their own copy of the database or whatever storage dependencies are appropriate for this particular application. And then some other targets that are used by the integration build, like packaging the UI, packaging the database, things like that. And so you can see our private build, it's kind of our default PowerShell function here. And the CI build we can use on a build server, okay? All right, so that's the private build. And let me just come back and let's see if it worked. Okay, yeah, there it is. So we can see our code coverage in each of the test run. There's not a whole lot of tests here. There's 3 integration tests. This is the first one. There's 14 unit tests right here. And it's running the same things as if you were to come in here and run these tests yourself. But you want to do them command line. Okay, now I know that I'm ready to commit, and I can do that. All right, so that's private build. Now let's go on to test-driven development. And what I want to highlight about test-driven development is its genesis. And if you've never read the original Kent Beck book, Test-Driven Development, I encourage you to read it. It was the book that kind of brought the method of test-driven development to the forefront. And the original book is written with Java syntax, and there is a book with C# syntax on the market now, but it's just a mindset. We are going to drive the development of our actual code from a test that is failing because that code isn't there or the code is wrong, okay? So let me just, if you're used to writing some tests, but you've never actually gone through the mechanics of test-driven development, let me just kind of show you. So let's, let's run our application here. Control F5, spinning up the application, and it's gonna come up here. All right, let's say this weather forecast. This is a standard Blazor app. Actually, this is pulling from our database. But let's say, our fetch data grid and fetch church bulletin. Let's say this right here, regardless of the data that is in the database that's coming back, we want the place to be in all capitals. I'm just making up a feature here. So we have our church bulletin. These are just things that happen at a church or place of worship. That's our sample application. Let's just come into our unit tests. And we actually have already a church bulletin item tester, which has a little bit of logic, and it has a few things like, well, we're not actually testing any properties. So let's just, let's do a test right here. And by the way, I'm using the ReSharper add-in, so it makes it where I can code forward. And let's say that place should be all caps. All right, so new church bulletin item. Let's see. Do I have to put in some other stuff? Place equals lowercase. All right. And I'm going to pull that off into a variable. Okay, what I actually want, item.place, should be, it actually should be lowercase. I know it's kind of confusing. So let's save that. Let's run, and you can see the shortcut keys I'm using in the upper right. It's not different. It should have been lowercase, but it was lowercase. Okay, so that's that. All right, so this doesn't work. So I have a red test. Okay, that's what we want. Red, green refactor is kind of test-driven development. So I have a red test, and you know what? I'm gonna go into place, and I definitely could create, I could create a setter, a set logic that actually forced it to uppercase. And I could do that. But you know what? I likely have other places in the application, or I'm just kind of thinking ahead. I will. So instead of that, you know what? I'm going to create my own string. Let's say, is it uppercase string? I'm going to create an uppercase string. And you know what? I'm going to create that type, and it's going to be over here. First thing I want to do is to move it to its own class over here. Close solution item so you can see it's uppercase. Again, I'm using a lot of keyboard shortcuts. I'm not reaching for my mouse very much. And we have this. I'm going to, let's see, private string value, and then we are going to, let's see, create it from an instructor. There we go. And I think, yeah, I think that'll be good. So I'm gonna close that out. Uppercase string. Let me close that out. Save changes. Yep. Let's go back to our test. Tested and happy. Can't even compile. Why? Because this doesn't even work. Okay. So let's see. Place equals lowercase. The type name. I actually need to actually implement this something. I'm setting it as a string. So let me come in here. Let me go back to my type. And I need something. I need public static implicit operator. There we go. String value. And then I'm going to say, I think that'll probably do it. The implicit operators allow me to just take simple assignments straight from there. So, okay, so Control Shift B. Now it compiles. Does it? Yes, it does. All right, let me run this test again. And of course it doesn't. It should be, okay, but it was, yeah. So that's not happy at all. So let's come back. All right, it should be lowercase. All right, so this is where I actually need to do a little bit more to make the uppercase string have some more intelligence. So I don't want to put all this logic in the church bulletin item when I really need a test for uppercase string. So I've done enough to compile, but I actually need to create another test fixture. So this is going to be, caps lock is on. Let me do that again. Test fixture, uppercase string tester. There we go. Test should be assignable string. And so we're going to say new uppercase string. Actually, I want to do the type. Uppercase string. There we go. Equals ABC. There we go. And then make sure it assigns back. String S2 equals S. And then S2, let's just make sure it's a string representation, equals S toString. All right, now that doesn't compile because I haven't done the operator back the other way. So yeah, this isn't going to work. Okay, so let's go back to uppercase string. We have something that's not actually compiling. We need the operator back the other way. So public static, implicit operator, string. There we go. Return value toString. Okay, actually, that's not the. I actually have a trim decimal that kind of does the same thing in this code repository if you want to look at it. And it kind of does static implicit operator decimal. Yeah, there we go. Okay. So implicit operator string. And anytime this does this, go back. Okay, what is it not happy with? Public static implicit operator string value return value dot value. Okay, so that's really what we want. And it's not happy because user-defined conversion requires restarting. Oh, it's the application starting. Okay, let me close that down. All right, making me think there's a syntax thing that I was missing. All right, can I convert from string? Oh, over here. Okay, I'm gonna stay in with this guy right now. And toString returns a string that represents a string. Cannot convert from string to format provider. Okay, so what's the navigation on this? Oh, that's object. I need to override string. All right, so this is test-driven development. I have a test that's failing, and I want to kind of go through and do everything. You know what? I think I need to override toString. And then this is going to return value. And this is going to operate invariant. Okay, now is this going to be happy now? Let's see, what is this? Can I convert from string to I format provider? You know what? Let me just do that. Is it happy there? S dot S toString. Sometimes the type's good. Well, I'll chase it down later. Variable result, and then result to S, result to should be result. Okay, so to run this test, whether I need to call toString or not, upper does not contain a definition for should be. Oh, because it's shouldly. And the best extension requires receiver type string. Ah, okay. Let's just do that. Is that what it was worried about? Requires a receiver of string type string. Ah, because I am in the world of no nulls. I'm still getting used to that from .NET 7. Should be. Why isn't this one working? Should Oh, this is a variable. System.string. System.string. Okay. Okay, it was the other code file. Control Shift B. Everything's happy now, and we're gonna Control TR. We're gonna run this test, and it's good. So that test runs, and then of course we come back here and we run all the tests, and should be all caps, should be lowercase, but was lowercase. So this is just an anomaly in the typing. So let's if it's equality, then we need equality to be here. So we just need our equality members. So let's do generation. We need to, let's see. ReSharper helps me out here with the equality operators. So Alt insert, we're going to do, there they are, equality members. All right, we're going to base it on this, and we get this stuff for free. Okay, and I'm not going to go through equality, but you got to have a hash code, you got to have overriding equals. ReSharper just generates this boilerplate based on the value being what we're actually delegating equality to. And then also we have additional operators right here that does it for us. So let me go back to my test, and let's make sure that this test is still working, and let's run all of these tests again, and let's see what happens. Okay, so now that works, but should output friendly place. Ooh, sanctuary versus sanctuary. This is an old test, so we are materially changing the behavior. So we're going to refactor that, run that test. It's good. And then finally, once we're done, we come back, we run all the tests again, make sure that all the tests are passing, and that is test-driven development. And if you have not read the book, Test-Driven Development, I highly encourage you to do that. All right, the next one is onion architecture, and let me just pull up the architecture diagram of this particular solution. And this is the structure of Visual Studio, the Visual Studio Solution structure. And notice we have our core project at the middle. We have our other projects around it, kind of like the layers of an onion. Now this is a very, very simple one. Of course, we have integration tests off on the side, unit tests off on the side. And so as you build it up more and more, you want to make sure that the libraries that integrate with the dependency are towards the edges and reference the core library. The core project in this Visual Studio solution is the most important thing in your application. It should have most of your code, all of your logic, business logic, your entities, your abstractions. Everything else is just an interface to something else that your application doesn't control. Okay, so that's really, really important. You want to use that for dependency management and proper factoring, and that is going to increase your quality whenever you have a clear structural pattern like onion architecture. All right, let's go to the next engineering practice, which is actually two of them: static analysis and inspections. Capers-Jones, probably the most prolific quality researcher of our time, says if you do upfront inspections and if you use static analysis before testing begins, and he's talking about user acceptance testing, he's talking about product management, customer-based manual testing, he's not talking about automated testing, then your schedule will be shrunk by at least 50% and your software quality will be above 95%. So let's take a look on what that means. So on static analysis, we want to put some analyzers into our build script. And if I was to, let's say, let me introduce a problem. If I'm going to come to, let's see, church bulletin item, and I just start unchecking these guys. And now I have this warning, right? So if I do a compile, then in my output, I'm going to have, or in my error list, I'm going to have a warning, okay? There is a built-in static analyzer to the compiler. These are the Roslyn compilers, used to be FXCOP. You can add additional rules in here, but we get a lot of rules for free, okay? And so that's a warning. And that is a potential surface area for bugs. We don't want any surface area for bugs. It's so easy to prevent it. And so we want to turn warnings on by default. Now, in the core project and anywhere else, I can go into properties and there is a checkbox that is, treat warnings as errors. And there's also .NET analyzers and all that stuff. But I'm actually going to come to our build. And when we compile, I'm actually going to set treat warnings as errors as true across the entire solution. So I don't have to go through every CS project and treat warnings as errors and have something else in every project. And then when I add a new project, I have to remember. And you know what? Sometimes when you're developing, you need to be able to just get something working and have some warnings and then clean them up. That's just reality. So what I found is it's best to put this into the build for the entire Visual Studio solution. All right, the next one is inspections, formal inspections. Well, we don't want bureaucracy. So what is a formal inspection? It means it's checklist driven and it's done the same way every time. So and the best place for this, by the way, is in a pull request because you have a second person inspecting a change, all right? So how do we make that a formal inspection? Well, let's come up and let's just look at a pull request that I've already prepared. Let's open it up here. And look, in the pull request, there's a submitter checklist and an approver checklist. And these are checkboxes. Now there's 3 that have already been verified. And this is a checkbox. Like GitHub is actually saving the state that these things have been checked off or these things have not been checked off, okay? And you can use, commenting and all that because it, may take a little while until the approver checklist is completely done. But if you approve this pull request, you as the approver are stating on your reputation that this change met everything on the checklist that your team decided should be there. I've put a few items here that I think are probably reasonable for every team. The issue is clearly tagged, the issue number, the build and all test suites are passing, the static analysis that you've chosen for your team runs, whether it's just the treat warnings as errors, which everybody should use, whether it's Independ, whether it's Sonar Cube, whether it's a TypeScript or JavaScript analyzer or a Americans with Accessibilities analyzer for HTML, for compatibility with screen readers. There are static analyzers for everything. All changes delivered with accompanying tests. You can't have a post checklist to make sure that everybody used test-driven development to drive the change, but you can verify that the tests and the code come into source control together. Okay, you can verify that. And then other things. Okay, now, how do we make this automatic? Let me just give you a little tip. Let me go into the GitHub repository in here. And if you have a file called pull request template, then that essentially the contents of it will be pre-populated in your pull requests. And so if I just show you what I put in here, literally it's Markdown. And when you created a pull request, this was automatically put in there for you. So if I just demonstrate for you, go to pull requests again, and let's do a new one. And I'm just gonna flip the branches around so it'll give me the create pull request button. There it is. And if I hit create pull request, this is the default. So as the submitter, I even have a submitter checklist. Hey, you know what? If some of these are done, maybe I'm not even ready to submit my pull request. All right, so that elevates a pull request into a formal inspection. And so you need to implement formal inspections in your team. All right, so let's go on to the next one. And that is continuous integration. All right, I have in here GitHub Actions that's automatically triggering every time. It's running the build script on every branch, and I can show the build script here because of course this already ran, and I can show you all of the output from my build. Okay, and I also have on Dev Clear Measure Labs, also have a public project here where you can see the same running here. And at the end, we package up our deployable artifacts and save them into Azure artifacts. And these are the NuGet packages for everything needed to deploy. Okay. You need continuous integration. That's your team has a server, which regardless of branches or whatnot, any change that's made and shared by the team goes through the same build process with a few extra things and make sure that everything's in order. And so you want to add more and more things to your build. And then automated full system acceptance tests. Now, we ran our build and you saw Chrome popping up, but right here I have acceptance tests and they actually pull up the browser, and I've created another Programming with Palermo episode about those. But here's a Selenium test, and it just finds, it's a test, arrange, act, assert. It finds different elements, like it finds certain text. It finds a button and it clicks a button, and then it can look at grids, it can look at any part of your HTML and make sure that what you expect it to happen happens. And it's just an in-unit test. Literally, you can run it locally if your application's running it locally, but you definitely want to run it on a fully deployed environment. So those right there are the elements that you really want for establishing quality, which is the first pillar of the Clear Measure way. Well, that was a quick run through on the engineering practices which help you establish quality. And every team needs at least 95% quality. And you want to establish that upfront and maintain that going through. And so from test-driven development to onion architecture to formal inspection, static analysis, continuous integration, your private build, your full system acceptance tests, you need this baseline 7 engineering practices. And then of course, depending on your situation, you add more, but those are just the tickets to the game. So hope that helps. May you and your team establish top-notch quality right from the get-go and not have any bugs. God bless.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at palermo.network as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.